let's start with the basic models that we had before. Basically, we can say in maybe 1943, okay, that we had the mathematical models for the neural network. So the basic concepts that they came from math and mathematical models. For the neurons, as we discussed, that was the base of the idea that how we can make a model by looking at what really our brain is working and what is happening in our neurons, in our body. So the idea was developed as mathematical model of neurons many years ago. Okay, so 1943 maybe can be represented as the first year for this kind of models. And then in 1950s, as we said, like 1958, we have the very basic models that only with one layer. Okay, so the single layer perceptron was introduced. So there was a kind of revolution in this area to introduce something new and make the math models, neurons, a little bit complicated by adding a layer between and the kind of function that can work there to give us a better output. Okay? So maybe solving the XoR problems was the next one that we can mention. The backpropagation in more or less 1918. A little bit more complicated models that we might say multi-layer perceptrons. So rather than this single layer perceptron, let's make it more complicated with the multi-layer perceptrons. That they were also in 1990s, so maybe 1997. Okay. And then we had some models that they are very well known, the RNN and LSTM. Okay. So that They have a very nice application also in the financial matters and for the financial problems, and make a good forecast for future combination of this RNN and the LSTM, and this kind of models works very well. So these are the models that we might say we had them in 1997, and then the CNN will be mentioned here, okay? So after that, after 2000, if we consider here as 2000, we had some kind of models that they were based on the statistical concept, mostly the models that we could have with a good mathematical background. The SVM is one of them. So SVM might be the most important thing that we can mention for this time. And the people start to think that if we can have a kind of model with SVM with a good mathematical background and very strong mathematics and proofs that we had for different parts of this modeling approach. What would be the use of all of these complex models that we might really have some problems to understand what really is happening inside and to interpret it or discuss it for the people in a very simple way. So at this time, we can see that there is a decline in the popularity of the neural networks and what we could have as the deep learning, but it was not only the reason, the lack of the computational power and memory and the CPUs and the computers that we had till then. They couldn't support all the calculation that we need for these complex models. So some other models like SVM, they could work better, and they could be the first choice to make a model, and the performance of the models also was not very, very different. So they were good candidates for the financial problems and for forecasting and also for classification problems. What we can say happened after 2000, it was the evolution in the amount of the data and the computational power that we had. So it makes the life easier to use the models like what we have in the neural network and the deep learning. So we can see a back trend to neural networks and the complex models, and the new kind of data that they were not the tabular data similar to what we had before, but like the images, the voice, or the videos that we wanted to analyze at that time, or the text mining, for example. So the ImageNet, for example, was something that was added, okay, between 2000 to 2012. We can also mention the Google Net, for example. So at this time, we can see that neural network and deep learning came back to the play and modeling approaches for complex models with a huge amount of data, and by using the computational power that was added at that time, and also the memory that was cheaper than before, and all the facilities that we have nowadays for the big data platforms. So what we can say that we had different kind of models here, the kind of combination of the models that we had before. And finally, we had the ChatGPT that we can say in 2022 or 23, the different versions. They are nowadays based on all of these deep learning models to produce us not only the models to predict something, but also to produce something. Okay, so they can make the text, they can make the stories, the novels, the books, some research works. They can answer us rapidly with accurate answers by gathering the information from the different websites or the data source that they gathered data before from the net. So they can understand all of them. They can summarize the answer and provide the answer in a very natural way that the people are speaking. So it's not only about the chat, it's not only about text. We can see that they can also produce some images that they are very interesting based on the explanation that you will provide for them. So all of these technologies are based on the models that they evolved by time, started from 1943 or maybe 1958. Until now, we can see that by using the computational power, by using the technology that nowadays we have, we can do all of these interesting works and provide the technology about making the new things for the humans and maybe make the life easier. Okay. So as we said, there were some bottlenecks of deep learning, mostly related to the limit of the computer hardware, to computational power, to the memory. And now we have the new technologies. We have the GPUs, okay, that they are much faster in calculation rather than the CPUs that we had before. So the combinations between the CPUs and using the computational power that the GPUs can add, they will give us the opportunity to use the deep learning models more than before. Also, we can mention some technologies like what we have now for the big data. So the Spark is one of them, okay? Apache Spark. We have the data lakes, for example, so not only traditional data sets, but the new forms of data with the facilities to record them, to save them, to put them in memory, and then use them for the models and ingest them into our models. And we have also the TensorFlow and the different technologies that they can help us to deal with the deep learning models and the complexity that these deep learning models are bringing. But the story nowadays is completely different with what we had before.